Vertical sand media filters. Principles of operation. The principle of sand media filtration is quite straightforward. The irrigation source water is pressurized and introduced into the top of the media tanks. A diffusion plate in the top throat of the tank serves to reduce water velocity and distribute the water evenly across the top of the media bed. The media bed is a layer of size-graded crushed silica sand, about 16 inches in depth. The contaminants in the water are captured in the media bed, and filtered water passes into the discharge manifold at the bottom of the tanks. Sand media filters are effective at filtering both organic and inorganic contaminants. The large size and three-dimensional nature of a media bed provides more surface area and has greater holding capacity than many other types of filters. Determining filter capacity and understanding the backwash function, cleaning of your system, are among the most important aspects of successful filtration. These operations and more will be covered in the following pages. The key to superior media filtration is the effective removal of the captured contaminants from the media bed, commonly referred to as backwashing. Located in the bottom of every FlowGuard media filter is a highly engineered underdrain system that is designed to perform two functions. First, it must not allow any media sand to pass through the filters and into the irrigation system. Second, during the backwash operation, it must allow the flush water to be evenly distributed throughout the entire media bed, with no pockets or dead spots. This ensures that the media is lifted and uniformly rinsed free of contaminants in an efficient manner. The FlowGuard underdrain is made up of a series of stainless steel wedge wire elements attached to a stainless steel spoke system that covers the entire bottom of the tank. The large spoke system allows for a better distribution of the backwash water to the individual wedge wire elements. The wedge wire is effective in preventing media from entering the irrigation system and by design does not get obstructed with media. Covering the wedge wire elements is a layer of gravel. The purpose of the gravel is to deflect the high velocity backwash water and create a very uniform flow, capable of gently lifting the media in the most efficient manner possible. The efficient backwashing results in cleaner media, sand, and shorter backwash cycles. The backwash operation. The backwash operation is accomplished by sequentially flushing each tank in a series of 2 or more filters. To backwash a tank, The small three-way control valve on the backwash valve is either manually or automatically turned to the on position. This allows pressurized water from the hydraulic command system to fill the actuator diaphragm and push the piston into the backwash valve. Connected to this piston is a two-sided valve plunger. In the non-actuated position, the spring-loaded valve is seated between the tank inlet and the backwash discharge manifold. This prevents water from escaping into the backwash system during the filtration mode. When actuated, the piston and valve seal move across the inlet port of the tank and seat against the intake manifold, where unfiltered water enters the tank. This single motion prevents unfiltered water from entering the tank and allows pressurized filtered water in the irrigation system to escape backwards through the tank and out the backwash manifold. Because the backwash flow is dependent upon a source of filtered water from the irrigation system, all media filter systems require at least two tanks, one to supply filtered water for the other tank that is flushing. It is important to keep in mind that only one tank should be flushed at a time. The backwash throttle valve. The backwash throttle valve is placed on the backwash discharge manifold to control the volume of water that can escape during backwash. Obtaining the proper flow rate of the backwash water is critical for effective flushing. Too high a flow rate will flush all of the media out of the tank. Too low a flow rate will not allow the media to gently lift, fluidize, and flush the contamination from the sand. The proper flow rate is dependent upon tank diameter, as shown in the accompanying table. The most common way to adjust the backwash throttle valve is to manually set one filter to backwash with the throttle valve fully closed. Slowly open the throttle valve until small amounts of media are evident in the backwash discharge. It is most desirable to place a nylon stocking or fine mesh screen over the discharge pipe to check for the presence of media. If this is not possible, a sight tube can be used as an alternative. It is desirable to have a slight amount of media discharged during the backwash. You should expect to lose 2 or 3 inches of sand per season. 100 to 200 pounds per 48-inch tank. Although the media bed is about 16 inches deep, it makes the most sense to try to keep the contamination in the top couple of inches. This allows you to quickly rinse the sand during a backwash sequence. If the lower depths of media becomes contaminated, it will take much longer to rinse the sand, and you run the risk of contaminating the underdrain. In order to prevent contamination from reaching the lower depths of the media bed, proper backwash frequency and duration must be determined. The backwash frequency. The backwash frequency is dependent upon the characteristics of the contaminants present in the source water. Although the automated backwash controller is equipped with a logic circuit to initiate a backwash when the pressure differential across the filters reaches a given level, typically 4 to 6 psi higher than when the tanks are clean. It is oftentimes more desirable to initiate a backwash sooner than this. Very fine silts, for example, are able to migrate deeply into the media bed before an appreciable pressure differential is reached, and they become difficult to remove. Algae and other organic matter tend to harden and cake with time, cementing the media together, if not flushed on a daily basis. Therefore, it is a good idea to set the controller clock or manually flush the filters once daily as a minimum. For heavier loads of contaminants, perhaps every 2 to 4 hours. In many installations, the water quality changes during the season, and the irrigator is wise to adjust the backwash frequency to the correct conditions. The backwash duration. The backwash duration is dependent upon the characteristics of the contaminants of the backwash frequency. A 90-second flush duration should be adequate if the captured contaminants are large particles such as flakes of rust, weed seeds, and leaves, which will be laid out upon the surface of the media bed. If the contaminants are fine silts that migrate into the media bed, the backwash duration becomes more a factor of how deep they have migrated, which is directly related to how often the filters are flushed. This is why it is important for the irrigator to periodically observe a backwash sequence and confirm that the duration is of sufficient length to remove all of the contaminants. The backwash water should run clear for 15 to 20 seconds before the valve is signaled to close.